For our next sample problem, now we're going to be converting more complex units, wherein we are converting volumes. So we have inches cubed to meters cubed, and then we also have two dimensions. So we have a unit in the numerator and then the denominator. We'll start with converting volumes. And so we have 3.7609 times 10 to the third. And that is inches cubed. And we have to take it to meter. And notice how we are converting American units to metric unit. And you have your handout number 1, where you have those convenient conversion factors. And so if we look at it, we can convert inches to centimeters. And then from centimeters, we know how to convert to meters. Okay, so we have, according to the table, 1 inch is equal to 2.540 centimeters. And notice how if we leave it like this, and if we were to cancel, we're only canceling 1 inch in the denominator, but then that leaves with inches squared. And so what we're going to end up doing, and because this is volume, we're going to have to do this 3 times. So the second one cancels out the second inch. And then this last one cancels out the last inch, the unit inch altogether. And this is in centimeters, centimeters. And what that does is it also multiplies centimeters times centimeters times centimeters. And so we're still in that volume unit. All right, so all the inches will cancel out. But we're still left with centimeters, which we don't want. We want it in meters, so we're going to carry on. And one way to write this out so that you don't have to write the units 3 times is that you can just put it in parentheses. So we have 1 centimeter, and you're going to need your table for this if you're not familiar with the prefixes and their values. So we have 1 centimeter is going to be equal to 1 times 10 to the negative 2 meter. So the value is 1 times 10 to the negative 2 meter. We encase that in parentheses, and then we're going to cube it. All right, so let's go ahead and enter this in our calculator. Okay, so we have 3.7609 to the third. We have to multiply that by 2.540. So you can enter it in your calculator as it shows on the paper. So times 2.540 times 2.540 times 2.540. So you can enter it that way. Or you can also enter it using the functions in your calculator. So we have our last value here times, just make sure that you are using the parentheses correctly. So we have 1 to the negative 2, and then we are going to go ahead and cube the whole thing. And so our final answer is 6.1630 times 10 to the negative 2nd meters cubed. And that's our final answer. Now let's work on the third example, wherein we are working with 2 units, one in the numerator and one in the denominator. So we have to take 238.9, that's pound for feet cube. So we have LB, and then this really is in the denominator, so that's 1 feet cube. And we have to turn the numerator into micrograms. So again, we're converting American unit to metric. And then feet cubed to centimeter cubed, the same thing, American unit to metric. And just force of habit, we're going to work on the numerator first. You can certainly work on the denominator if you want to. But let's go ahead and turn pounds into microgram. And again, let's plan out our conversion. So we have pound, and we have a conversion factor from pound to kilograms. And then we can turn kilograms to grams, and then from grams to microgram. Okay, so we have 1 pound, according to our table, is 0.45 kg. And if this is confusing to you at first, you can go ahead and just cover up the bottom so then it looks like the same thing that we have been doing. And then you can just focus on that. Okay, the pound will cancel out. And then let's figure out our conversion factors. So we have to go from kilograms to micrograms. And you can still certainly write out your conversion factors if you need to. So because we're needing the unit kilo, we know 1 kg is equal to 1 times 10 to the 3rd grams. And then we have to also use the unit micro. So 1 microgram is equal to 1 times 10 to the minus 6 grams. So these are our conversion factors. We'll just transfer it over our table. So 1 kg is 1 times 10 to the 3rd grams. Units cancel out. And then we use our second conversion factor, which says 1 times 10 to the minus 6 grams is equal to 1 microgram. Okay, and I actually cannot have equal yet because we're not quite done. So we did turn the numerator to microgram, but we're still needing to solve the denominator. So turning feet cubed to centimeter cube. So we must carry on. All right, looking at our table, so we have feet is equal to this many meters, and then we have to turn it into centimeters, so we can do from feet to meters, and then from meters to centimeters. Okay, and so because this unit is in the denominator and we want to cancel it out, we do the opposite. So that means the unit feet is going to be put on top. And according to our table, 1 foot is 0.305 meters. And again, the same thing, because it is cubed, we have to cube the entire thing. Let's cancel out our units. So feet is gone. We don't really want meters, we want it in centimeters, so we need another conversion factor. And according to our table, 1 centimeter is going to be equal to 10 to the minus 2nd meter. Okay, being mindful of where the units we need to cancel. So meter goes on top. So 1 times 10 to the minus 2, and then 1 centimeter will be in the denominator. And again, the same thing, we have to remember that it is cubed, so we have to cube this entire thing as well. We cancel out our units, so meters cancel out, leaving us with centimeter cube as our final unit for the denominator. All right, let's go ahead and enter this in our calculator. So we have 238.9 multiplied by 0.45, again because the value is in the numerator, the value that is not 1, and then times 1 times 10 to the 3rd. Okay, now this value, the value that is not 1, and is now in the denominator. So we're going to go ahead and divide. Divided by 1 to the minus 6. So far, this is our answer. And then we have to tackle this last part. Okay, the 0.305 is in the denominator, so we're going to divide. So that's divided by, and it is cubed, so we're going to go ahead and do that as well. 0.305, this whole thing is cubed. So far, this is the answer. And then the 1 times 10 to the minus second is in the numerator, so we're going to go ahead and multiply. And we have to remember it is still cubed, so we have to do that as well. To the minus 2, the whole thing is cubed. And so our final answer is going to be 3.7890 times 10 to the 6th. And our final units are going to be whatever we did not cancel. So we have microgram over centimeter cubed. For the next slides, we're just going to go over the important SI units that we will be using in chemistry. The first one being length. The SI base unit of length is meter, or lowercase m. A meter is the distance light travels in a vacuum in 1 out of the speed of light of a second. That is the physical quantity that the unit meter is based out of. The next quantity would be volume, and volume is defined as the amount of space matter occupies. The SI base unit of volume is the cubic meter, or M3. In chemistry, the non-SI unit will be liter, or capital L, and then milliliter, which would be lowercase m, capital L. Mass is the next quantity, and mass is defined as the quantity of matter an object contains. It's the amount of particles contained in that substance. The SI unit of mass is the kilograms, or kg, based on a standard object, a platinum iridium cylinder kept in France. Note that mass and weight are not the same. And this is the prototype of where the unit kilogram is based off. Other quantities, density. We have the first worksheet that you will be doing has a lot of density calculations. Density is an object's mass divided by its volume. We have this formula, mass divided by volume. Volume can change with temperature, so can density. That's why when we're working with density values, you will see that it will give you a value for density and then a temperature. So for instance, water will have a density of 1.00 grams per centimeter cube at 25 degrees Celsius. The density of a substance is a characteristic physical property and has a specific value. The SI unit of density is kilograms per cubic meter, so that would be kg per m cube. But in chemistry, we also use grams per liter, so that would be grams per decimeter cube, or grams per ml, or grams per centimeter cube. Please note that a liter, so 1 liter, is equal to 1 decimeter cube. That's a direct equivalence. And then 1 ml is directly equated to 1 centimeter cube. Also note that densities of gases are much lower compared to those of liquids or solids. Here is a table of the different ways to manipulate the density formula based on what you're looking. So to find density, it's going to be mass divided by volume. To find mass, it's going to be density times volume. And then to find volume, it's going to be mass divided by density.